Why is Q value essential for reinforcement learning? Imagine teaching a robot to navigate a maze or a game-playing agent to win. How does it figure out which moves are best? That's where the idea of Q values comes into play. Reinforcement learning is a way machines learn by trial and error, kind of like how we learn from experience. The robot or agent tries different actions, gets feedback, and learns what works best over time. But how does it decide what to do next? That's the big question Q values help answer. In reinforcement learning, an agent faces many different situations called states. In each state, it can choose from different actions. After taking an action, the environment gives a reward, which is like a score telling the agent if it did well or poorly. But just looking at immediate rewards isn't enough. The agent needs to think ahead and consider the rewards it can earn in the future. That's where the Q value or quality value becomes important. A Q value estimates how good it is to take a specific action in a specific state, considering the rewards it can expect to get over time. It's like a scorecard that predicts the total future rewards if the agent chooses that action and then keeps making the best choices afterward. This helps the agent balance between actions that give quick rewards and those that lead to bigger rewards later on. Q values are used in algorithms like Qlearning, where the agent builds a table of all possible state-action pairs. The table gets filled out as the agent explores the environment, updating the Q values based on what it learns. Over time, this table becomes a guide showing which actions are most likely to lead to success in each situation. In more complex environments, like video games or robots with many sensors, storing a table for every possible situation isn't practical. Instead, neural networks are used to approximate Q values, allowing the agent to handle high-dimensional data like images or sensor readings. This approach is called deep Q networks and helps machines learn in complicated settings. Q values also reflected a core idea in artificial intelligence: learning from experience. They show how machines can improve their decisions over time, much like humans do when faced with new challenges. For example, ChatGPT improves its responses based on feedback, and image generators like Dull or Midjourney get better at creating images through repeated training. Understanding Q values also raises important questions about how machines balance exploring new options versus exploiting what they already know. If an agent always exploits, it might miss better strategies. If it explores too much, it might perform poorly in the short term. Finding the right balance is key to designing responsible and effective AI systems. In the end, Q values are essential because they help reinforcement learning agents estimate the long-term value of their actions. They guide machines to make smarter decisions, whether in playing games, controlling robots, or powering AI tools like chatbots and creative image generators. Knowing how Q values work helps us see how machines learn to make choices that lead to better results over time.